Hi, this is Route Optimizer, a web application to improve routing efficiency in logistics with a dynamic routing algorithm. Now let us consider a scenario with a few drivers and destinations to reach. Fill the required coordinates. Sample coordinates have been filled here. We have the latitude and longitude values for two drivers, two destinations, and new point. Click the Get Route button to get required directions. We get two outputs, one with directions from classic routing algorithm and another through the meet approach, which is the optimized routing method I'm introducing here. Let us go over them one by one. First, the classic one. Here are 5 markers representing the positions of the concerned entities. Driver 2 was already assigned to deliver at destination 1, and driver 1 is now assigned to deliver at destination 2. Assume that driver 1 starts at a physical store where the deliverables can be loaded, or that both drivers carry predicted deliverables in advance. After the route assignments just mentioned, a new delivery pops up, which is the new point. Now, what would happen in the classic approach? Driver 2 would take this dark blue route to destination 1, and driver 1 would take this dark green path to destination 2. Route 1 delivery will be completed first as it is shorter, and only now this free driver, that is driver 2, will be assigned to the new point, which will be completed through this light blue route. These are the various metrics for the classic approach just discussed. We will come back to this. Now, how can we optimize this? I was thinking of the same, and that is when I was intrigued by the possibility of letting two drivers meet to exchange deliverables, which led to the optimized meet approach. The situation is exactly the same as above. Driver 2 was on way to destination 1, and driver 1 was assigned to destination 2. But when the new point popped up, if feasible, we find the closest point between the drivers and let them meet there. Here, they hand over the deliverables to each other such that one driver is able to make the original two deliveries and the other heads to the new point. That is, driver 1 and driver 2 meet at the midpoint through the red and green light green lines respectively. Now driver 2 heads to the new point through this pink path, and driver 1 from the midpoint or meetup point reaches the other two destinations through this dark green path. Let us compare the approaches. We can see that in the classic approach, one destination ended up having a bad receive time, but the receive times are well spread out in the optimized approach. What is this within buffer field? Routing problems take into account unpredictable external factors and add an extra duration to the expected duration. We can see that the optimized approach has duration within the buffer. Moreover, an important observation is that we have saved 407 meters by using the meet approach. Apart from saving gas, time, and money, the meet approach gives us two more advantages. First, being that one of the issues in the delivery industry is the number of deliveries a person is expected to complete a day. With this approach, the path taken to meet another driver could also be considered a delivery, and this saves distance traveled as well as improves delivery experience of the drivers. The next advantage is that as we use the meet approach and collect data from it, we can analyze where two drivers often meet in a particular region, and that spot is an ideal location to start a new physical store from where deliverables can be loaded. This is a huge advantage as it would drastically improve delivery times for nearby customers, and we are taking the decision based on actual driver data. Hence, the meet approach is a dynamic routing algorithm that takes into account the instantaneous positions of destinations, drivers, and new points to decide if a classic route is to be taken or drivers should meet, exchange deliverables, and then take the new optimized route. Here are a few more examples of other scenarios and their corresponding conclusions. The application was built using Python, Streamlit Web Framework, Folium Library, and Azure Maps Free Tier. I believe this optimization approach has the potential to scale. Thank you.